July 20, 1969, 4 minutes to touchdown. A 4-digit code lights the guidance computer. Nothing in the flight rules names it. The mechanism is simple. Jack Garman, 26, kept an unauthorized list of alarm codes at his console, small ink notes on a single card, marking which ones the descent could survive. Code 1202 meant executive overflow, the computer shedding lower priority tasks to protect navigation. Flight rules in 1969 were unambiguous. An unrecognized alarm during powered descent defaulted to abort. Without that card, Eagle climbs back to Columbia. The landing does not happen. Apollo 11 carried the EASCP package, a small passive seismometer that ran for about 21 days on the lunar surface before thermal limits forced controllers to shut it down. It was a first instrument, not a network. The real Lunar Seismic Array, ALSCP, was deployed across Apollos 12 through 16, station by station, and ran for years. That distributed network produced the moonquake data of the 1970s, the long baseline record that constrained the moon's anomalously small iron core. A curtailed program after an Apollo 11 abort puts those later deployments in serious doubt. Without missions 12 through 16, the seismic network is never built. The core signature is never measured. That signature was the physical evidence that separated the giant impact model from older capture and co-accretion theories. Without it, planetary scientists in the 1980s have no seismic basis for preferring any one origin model. Within 48 hours of the abort, Nixon's communications director Herb Klein faced a press corps that had spent a week building toward a landing. The White House had drafted contingency language only for crew death. A survivable abort had no script. Klein fell back on the line that the program continues, visibly improvised, visibly thin. The political cost was immediate. A mission that returned 2 astronauts alive, but accomplished nothing on the surface read. In the coverage that followed, as a failure the administration had no language to reframe. Mission Control's loop system was engineered to do the opposite of what Garman did. The architecture was explicit. No single controller's uncertainty, no individual's private judgment should determine an irreversible call. Procedures existed precisely to remove that variable. Garman's index card was, by the institution's own rules, a violation of that architecture. It introduced undocumented individual knowledge into a system designed to run on documented collective procedure. What the 1202 alarm revealed is that the violation was the system. The card was load-bearing. The 6 Apollo landings returned 382 kilograms of lunar samples. In the compressed program most plausible after an Apollo 11 abort, that figure collapses. Apollo 12 returned 34 kilograms in November 1969. Anything after that, under a curtailed budget, contributes only a fraction of what the full program gathered, well short of 382 kilograms. The exact shortfall depending on which missions survive the appropriations fight. Gerald Wasserberg at Caltech used isotopic analysis of these samples to fix the moon's age at 4.5 billion years and to document the late heavy bombardment, a period of intense cratering that reshaped the inner solar system. With a fraction of the material, Wasserberg's argument remains open. The data is simply not there to close it. Tom Paine had entered 1969 already under pressure. The Bureau of the Budget had requested a $1 billion cut to NASA's appropriation, and Payne's only real defense was that Apollo was delivering on a presidential mandate. An aborted landing removed that defense. Within 6 weeks of a July abort, the House Appropriations Committee would have reopened the FY 1970 hearings. The figure under debate shifts from Payne's, requested $3.7 billion toward $3.2 billion, a reduction large enough to cut the remaining lunar schedule from 6 missions to, at most, 3. This is not an argument against procedure. Procedure is what kept every other system on Eagle inside its design envelope that afternoon. The observation is narrower and harder to absorb. The 12:02 alarm was absent from official documentation because the specific failure mode it represented, executive overflow during powered descent, had not appeared in the formal test matrix. The gap between what the system had been tested against and what the system actually encountered was real. That gap was bridged not by institutional process, but by one man's private preparation, conducted against regulations, on a single index card, which means Eagle's actual reliability on July 20th was higher than its documented reliability. The system worked better than it officially knew how to work. The giant impact hypothesis was proposed in the mid-1970s, independently by Hartman and Davis, and separately by Cameron and Ward. Its first arguments were dynamical angular momentum, the moon's missing iron core, the geometry of a collision that could deposit enough material in orbit to form the moon. The Apollo samples did not originate the idea. What they provided was one of its critical empirical pillars. Oxygen isotope ratios in the lunar basalts were nearly identical to Earth's mantle, constraining the impactor's origin and the degree of mixing during the collision. Together with radiometric ages and compositional work, this gave the model its grip, a physical anchor that no competing theory could match. In a compressed sample program, that pillar arrives incomplete. The hypothesis still gets proposed on theoretical grounds. But without the isotopic constraint, it remains one possibility among several through the 1984 Kona Conference and beyond. In Moscow, Luna 15 was already in lunar orbit when Apollo 11 aborted. In our timeline, Soviet controllers rushed its descent on July 21, and the probe crashed, scooped by Armstrong's landing the day before. Strip out that pressure. With no American flag on the surface, no public defeat to absorb, Soviet planners had every reason to wait for a safer trajectory. The historical record shows Luna 15's crash was a navigational gamble taken under deadline. Remove the deadline, and a successful unmanned sample return becomes plausible. One task could credibly present as the first lunar material recovered by any nation. Here is the complication the 1202 story rarely surfaces. Garman's answer was not only correct, it was immediate and confident in a way that closed off further discussion. That speed was the asset, but the same speed, applied to a genuinely critical failure rather than a recoverable overflow, would have sent Armstrong and Aldrin into a landing sequence with a computer that was actually failing. The informal knowledge that saved the mission carried no built-in mechanism for knowing when it was wrong. The consequences extend beyond the moon. In 1972, NASA made its case to the Office of Management and Budget for the Voyager outer planet missions, a case built substantially on Apollo's demonstrated scientific return. Lunar samples had already reframed planetary formation theory. The argument was that deep space probes would do the same for the outer solar system. A diminished Apollo record with fewer missions and contested findings weakens that argument exactly when it matters. The Grand Tour alignment Jupiter, Saturn, Uranus, Neptune in a rare orbital configuration closes in 1977. It does not reopen for another 175 years. The political damage did not arrive as a single decision. It accumulated through narrative. By late 1969, the dominant press framing was not abort averted, but NASA reached the moon's doorstep and turned back because a computer generated a code no one could read. Senator Walter Mondale, already skeptical of large-scale federal technology programs, cited that framing explicitly in 1970 when he advanced his amendment to cut funding for the shuttle's predecessor. In actual history, Mondale's amendment failed narrowly. Without Garman's card, the arithmetic changes. What the 1202 alarm reveals is not a story about one prepared analyst. It is a story about where operational knowledge actually lives inside complex institutions, and what happens when it is absent. Garman's card existed because official documentation had not caught up with the system's actual behavior. The procedures said nothing about 1202 because no one had yet written the procedures. The real load-bearing structure of the mission at that moment was informal. 17 years later, the Challenger decision chain inverted this dynamic precisely. The engineers who understood the O-ring data most intimately, Roger Boisjali and his colleagues at Morton Thiokol, had raised their concerns through informal channels for months. On the night of January 27, 1986, formal management procedure overrode their informal assessment. The launch went ahead. The Apollo 11 case and the Challenger case are mirror images. In one, undocumented expertise entered the decision chain and the mission survived. In the other, undocumented expertise was excluded from the decision chain and the mission did not. The structural problem in both cases was identical. The outcome depended entirely on which direction the institutional pressure ran. The connection to Earth science is indirect but consequential. The isotopic and radiometric techniques refined under pressure of the Apollo sample program were the same methods geologists applied to ocean floor basalts to quantify spreading rates. Without that methodological sharpening arriving on the same timeline, the quantitative case for plate tectonics, still contested through the late 1960s, hardens more slowly. The consensus that formed by the mid-1970s likely extends into the 1980s, with practical consequences for earthquake hazard modeling and for resource exploration that depend on precise crustal chronology. The détente process that opened in late 1969 was shaped, in part, by demonstrated American technological credibility. Apollo's success was visible evidence of U.S. capability across multiple domains, not just space. An Apollo that turned back 4 minutes from the surface supplies a different kind of evidence. The Nixon administration's simultaneous SALT negotiations and opening to China both required projecting American competence and resolve. A visible failure of the most watched mission in history would have affected that projection, not strategically, not decisively, but in the accumulated atmospherics that shape how governments read each other's capabilities. Complex systems do not fail only when their components fail. They also fail when the knowledge required to operate them lives outside the system's own awareness. The Apollo guidance computer performed exactly as designed. The institution around it did not know what it knew, or, more precisely, it knew less than one of its members knew, and had no mechanism for closing that gap. Garman's cheat sheet was a load-bearing element of the mission that appeared in no load-bearing documentation. This is not a pathology unique to NASA in 1969. It is the normal condition of any organization operating near the edge of its technical knowledge. What the counterfactual exposes is not that institutions fail. It is that they routinely succeed by depending on informal scaffolding they cannot see, and therefore cannot protect. By 1984, the question of how the moon formed remained genuinely unresolved. The Kona Conference that year, in actual history, the meeting where the giant impact hypothesis gained decisive traction, convened without the lunar sample collection that had made that consensus possible. Researchers were working from Earth-based spectroscopy and the limited isotopic data available from meteorites. The conference produced no agreement. The leading hypotheses, capture, fission, co-accretion, each carried unresolved objections that only physical samples from the lunar mantle could adjudicate. Resolution was deferred, pending sample return missions that carried no funding and no launch date. Apollo 12 launched in November 1969, but inside the reduced shape the budget arithmetic had already predicted. The program continued. It was not canceled. What changed was its horizon. By 1970, Apollo 20 had been struck from the schedule. By 1971, Apollos 18 and 19 followed. The 6 landings that occurred in actual history, the geological traverses of the lunar highlands, the deep core samples, the seismic data from multiple sites, collapsed to 2. The television networks, which had cleared their schedules for Apollo 11, negotiated narrow windows for Apollo 12. The audience that had watched a first landing was watching history. Apollo 12 was a technical achievement. The distinction mattered in every appropriations hearing that followed. The card Jack Garman wrote that morning, or what may be that card, sits today in NASA's historical archive. It does not appear in the official Apollo documentation. It was never part of the formal procedures. It was, by the standards of the institution, unauthorized. What it did on July 20, 1969, was answer a question the institution had not prepared itself to answer in the 4 seconds available before protocol required an abort. The DSKY showed 12:02. The room went quiet. One man had a handwritten card. That is the actual load-bearing structure of what happened next.